Hey, physics class, Sam here. I want you to imagine something for me. Imagine a strongman standing in a field. He's got two ropes in his hands. One is tied to a tree, the other one tied to a horse who's running away from him and the tree. Luckily, he's able to withstand the tension forces of the two ropes and prevent the horse from escaping. Got that? Now imagine that instead of a horse and a tree, the ropes are tied to two horses, running in opposite directions with the strongman in between them. How do the forces in these two scenarios compare to each other? Are the forces in one scenario greater than the forces in the other scenario, or are they both the same? If we want to figure out the answer to this question, I suggest you follow me. If we want to figure this out, we should start by looking at the forces present in both the scenarios. Not considering force due to gravity and the normal force opposite it, the only forces the strongman experiences in either of the situations are going to be the tensions of the two ropes he's holding. Based on the fact that the strongman is able to hold his ground, we know that the two tension forces are going to be equal and therefore cancel out, giving us an F net of 0. Take a look at this. Have this pencil represent the horse, have this pencil represent the tree, and have the dowel rod in the middle represent the strongman. If I pull on the horse pencil, naturally this pencil and the dowel rod are going to come with it. But this pencil is supposed to represent a tree, which is supposed to be rooted in the ground and not move. So in order to stop it from moving, I have to pull on it with the force equal to the force that's being applied to the horse pencil, which in this demonstration is going to be its force weight due to gravity. For the two horses scenario, we know that the forces exerted by the two horses are going to be equal, because assumedly they're going to run away at the same speeds. For the horse-tree scenario, we already know that those two forces are going to be equal. And we also know that one of those forces is going to be equal to the force that a horse exerts when it runs. And therefore, by the transitive property, the other force is also going to be equal to the force that a horse exerts when it runs. And therefore, the forces in the two scenarios are going to be equal to each other. Before we wrap up, let's quickly take a look at a third situation. It's just like the first situation, but this time we have two horses running together instead of one. Unlike the second, where the horses acted against each other, these horses are acting in the same direction, with the tree acting against them. The forces experienced by the strongman are going to be twice what they were in the first situation, and hopefully not too much for him. One of the trickiest things about this problem is the fact that the answer seems so counterintuitive. Why does a situation with two horses have the same amount of force as a situation with only one horse? It's my hope that you now know the answer to that question. And as always, I appreciate your viewership.